Section B. Common non-electrical installations. B. I shaft lines and deck MACHINFRY. This section groups together a heterogeneous series of items of equipment common to all ships. They are the propulsion mechanism and propeller, the servomotor and the deck machinery. Also included is the hydraulic machinery, which is one of the drive systems most utilized for that equipment and which, to a certain extent, is a link joining them together. The other drive systems are dealt with as part of their own specific topics, steam and electricity. In brief, it should be said of each of the items of equipment dealt with here that the shaft line is responsible for transmitting the rotary energy produced by the main engines to the propeller. The hull pass-through is the stern tube. This is a part of the ship that requires special attention, as it allows the shaft to pass through while maintaining the ship's watertightness. The crew can be the fixed blade or variable pitch type, regulated by hydraulic systems. The former type is used on ships that are going to navigate at rather constant speed and power regiments, while the latter type is installed on ships with great variations in operation speeds, ferries, tugs, etc. Where the advantages of being able to adapt the pitch of the crew to the speed offset the disadvantage of greater size of the crew core and the difficulty of adjusting the pitch perfectly. On those ships where the power-to-speed ratio is very high, it is useful to employ nozzles that direct the flow of the water to the screw. More and more frequently, bow thruster with adjustable blades are being installed on ships to help maneuver the ship and permit the reduction or even elimination of tugs in port. Bow thruster. The steering system consists of a rudder which is turned by the steering gear engine through the spindle. The deck machinery consists of the ship mooring systems, winches, capstan, etc., and the winches of the running rigging, as well as the lifeboat systems. The hydraulic equipment is the hoisting machinery drive system that is coming very strongly online, first because it is very high performance and, secondly, because it is very easy to maintain, which helps to reduce crew size. Following are some points of information and practice cases involving the above-cited systems and components frequently used on board ship. Diagram of the bow machinery of a ship. 1. Shafts and stern tube. A. On very ship, the tall shaft extends outside through the stern tube, whose purpose is to make sure that seawater cannot come in, at the same time allowing the shaft to extend out and giving it a final support at the same time. B. In a water-lubricated bearing-type stern tube, which is lubricated by seawater, it is necessary to check that this water circulation exists, because if there is no water, this bearings would be damaged. This check is made during each watch by means of a tap located on the stern tube. The simplest way of checking while underway is to leave the tap party open. In this way, it is possible to check at any given moment that water is circulating inside the stern tube. Water may be supplied by a seawater pump and so guarantee sufficient clean lubrication. C. A stern tube equipped with a hydraulic closure has to be watertight at both ends, in other words, the part outside the ship and the part in the engine room, because, since it is a closed circuit, watertightness has to be total and there can be no oil losses. Therefore, it is necessary to note the consumption of oil on each watch, because abnormal consumption would indicate a loss of tightness outside, even though no leaks are seen on the inside. 2. Propeller. A. In any modern system equipped with a variable pitch screw, the blades are driven by oil pressure, so that in order to make any kind of change in blades, or even to maintain them at a desired pitch, it is necessary to maintain the pressure. In the event of a stoppage of the oil circuit, it will be impossible for the blades to operate properly. CIRCUIL in a hydraulically sealed stern tube. Illustrative diagram of a variable pitch screw. 3. Steering apparatus. A. In a hydraulic drive servomotor, there is, in addition to the main oil reservoir, another tank for automatic makeup of losses that can occur in the system by leakage through gaskets, plugs or stuffing boxes. This tank is connected to be pumps through tubes in which some suction valves are located, whose mission is to inject oil automatically into the installation when any loss occurs. To provide the necessary pressure, the makeup tank must be installed at a high point. 3. Steering apparatus. A. In a hydraulic drive servomotor, there is, in addition to the main oil reservoir, another tank for automatic makeup of losses that can occur in the system by leakage through gaskets, plugs or stuffing boxes. This tank is connected to pumps through tubes in which some suction valves are located, whose mission is to inject oil automatically into the installation when any loss occurs. To provide the necessary pressure, the makeup tank must be installed at a high point. 4. Deck machinery. A. On a lifeboat davit whose winch is equipped with a centrifugal bray, the latter whirs during the lowering operation to prevent the boat from dropping too quickly or roughly. Thus the boats are lowered without danger to personnel, preventing the boat itself from becoming unbalanced and hitting the water too hard, which could cause it to turn over especially in bad weather. B. On winch equipped with a constant tension system, the stress limiter acts by paying out the cable rapidly in the presence of an increase in tension until the tension can be reset by the limiter. If the tension disappears, on the other hand, the cable is taken up until normal working tension is attained. This prevents damage to the mooring lines without any reduction in the proper mooring of the ship. Constant tension on the winches prevents having to constantly change the tension on the moorings in port constantly because of variation in the tides, or for any other reason. 5. Hydraulic equipment. A. The cargo hydraulic equipment always functions in a closed circuit. In this way, the oil that circulates through the installation is always the same, except for minor losses through the stuffing boxes and the gaskets which are made up by the makeup tanks. Therefore, a high oil consumption level will be considered abnormal and the location of the leak will have to be determined quickly and the leak eliminated, because any loss entails the admission of air into the installation and a consequent decrease in performance. Diagram of a hydraulic system. B. In a hydraulic installation, the type of pump normally used is the variable flow rotary pump. Because of the peculiar working method of these installations and the variations in load to which the system is subject, this pump is the most suitable, because the flow changes in terms of engine requirements. The pump is a positive displacement pump and will operate at all pressures within its design range. B. 2 pumps and services. This topic includes concepts relative to the various types of pumps that are generally installed on all ships, both diesel and steam-propelled, as well as to the principal services, whose specific characteristics make them very important in the overall ship installation. These services are, the sea intakes and saltwater manifold, the bilges with the oily water separator and the sanitary systems. The role played by pumps aboard ship is very important, both for the proper functioning of the plant, fuel, lubrication, fresh water and distilled water feed, etc., and for safety purposes, firefighting, bilges, etc. In any event, it is normal aboard ships to have redundancy in these installations, or double use of the pumps, so that failure of the pumps does not cause greater damage. The pumps installed on ships are of the following types: centrifugal, rotary and reciprocating, each type being generally used as follows. The centrifugal pumps in the circuits where the fluids are not excessively viscous, such as salt water, fresh water, distilled water, etc. The rotary pumps in circuits with high viscosity fluids, such as oils, fuels, etc. Finally, reciprocating pumps are increasingly relegated to installations where liquid with a high air content has to be sucked up, such as happens in the bilges. The attached figures present some diagrams of each of these pump types. Following is a series points of information and practical cases pertaining to the different types of pumps, as well as to the various services mentioned above. Variable flow rotary pump. 1. Pumps in general. If it is noted, after a complete overhaul of a pump, that the bearings heat up more than normal and it is determined that the gasket is the correct one, the cause of this heating up is misalignment, which prevents the shaft of the pump from moving uniformly, causing the shaft support points, that is, the bearings, to heat up. 2. Centrifugal pumps. A. When a centrifugal pump starts in the manual operation mode, it is proper to keep the suction valve open and the discharge valve closed, because otherwise there would be an overload on the motor. Once started, the load will be increased by slowly opening the discharge valve. 3. Reciprocating pumps. The liquid end pistons of reciprocating pumps are equipped with rings made of hard rubber, bakelite or other similar material with a low limit of elasticity. Therefore, to position the rings in the corresponding piston, it is necessary first to heat them in boiling water for 20 or 30 minutes so that they will flex and can be readily installed, because otherwise they could break. 4. Rotary pumps. A rotary geared pump of the endless screw type has to have axial play and radial play between its shafts. In this way, the working pump will not cause wear or deformation of the shafts due to abnormal friction stresses between them. Rotary pump. 5. Sea intakes and manifold. A. The seawater manifold is equipped with filter. It has valves before and after each strainer to be able to isolate these strainers. Once they are isolated, they can be removed and the screen baskets taken out to be cleaned by mechanical means, usually by scraping and wire brushing. Seawater strainer. 6. Bilges. A. At the suction of the hold bilge drain, it is essential to install a non-return valve in the suction circuit to prevent water from returning to the hold in case of faulty operation, which would cause damage to the cargo that may be in the hold. B. The bilge pumps on a ship can discharge to the firefighting provided the pumps are equipped with an internal cleaned by circulating seawater through the inside of it, in other words, by intaking and discharging to the sea until this discharge water is completely free of oil. 7. Oily water separator. A. The separator's steam coil is used to heat up the mixture, causing a reducing in its viscosity. In this way, it becomes easier to discharge the oil when the temperature is low. In any event, contrary to what might otherwise appear, it has no positive effect on separator's performance. 8. Sanitary services. A. In a sanitary installation with hydrofor tanks, the pressure in the water heater is practically the same as that in the freshwater hydrofor tank. By means of this pressure, water reaches every point in the circuit, whether cold or hot water involved. Diagram of a sanitary water plant. B. In a system with sanitary water in a pressurized hydrofor tank, the minimum working pressure is that which permits water to reach any point in the installation. This pressure has to be lower than the pressure at which the sanitary pump automatically starts because, in this way, the system is never left without water nor is there any air seepage into the system. B. 3. Refrigeration installation and ventilation. Following is an analysis of the refrigeration installation and of the ventilation both as regards the cargo cooling services and the cooling of the ship provision rooms and accommodations quarters. The refrigeration installations that can be found on a ship are the following. Cargo hold refrigeration installation on refrigerated ships. Refrigeration installation for stores. Centralized air conditioning installation for accommodations. Independent air conditioning installation. All of these installations are becoming increasingly important on board ship both to achieve great crew comfort and for better care of cargoes. To the already classic transport of frozen goods, meats, fish, etc., there is more and more maritime trade in fruits and farm products, which require strict control both of the temperature and of any air pollution produced by the respiration of the organic elements themselves. The operating principle of the all cooling systems is the same in all installations. Differences arise from the size of the components and the introduction into the circuit of elements necessary to the control and proper functioning of the installation depending on the service that desired. In large capacity refrigeration systems, the cold is obtained by means of different coolants such as ammonia, freon and brine, with freon the most widely used. The following figure shows the most important elements of a refrigeration installation. Diagram of a refrigeration installation. The types of ventilation used on ships are of two kinds. Natural and mechanical ventilation in any form requires special attention on the part of the crew. Mechanical ventilation on a ship can be achieved in the following ways. Forced intake and natural exhaust. Forced exhaust and natural intake. Forced intake and exhaust. Each of the types of ventilation has a specific application on the ship. Thus, the first type is used generally to ventilate areas of crew quarters, cabins, messes, etc. The second procedure is generally used to ventilate areas where there are had odors or where any kind of gases are released, heads, galleys, purified room, etc. The third procedure is a combination of the first two and is usually used when more energetic ventilation is required, since it accomplishes the two missions of the other methods by introducing pure air and extracting, in addition to foul air, the gases produced by certain equipment. Therefore, this method is used extensively in the engine room. Following are some points of information and practical cases involving refrigeration and practical cases involving refrigeration and ventilation installations frequently used on board ship. 1. Compressors. A. When, after an extended shutdown of the refrigeration installation, it has to be restarted and it is noted that the compressor does not start, the most common cause of this problem is usually that the maximum protection device has been activated, thereby preventing the compressor from starting. 2. Evaporators. A. In every refrigeration the cooling effect is produced in the evaporator. This is where boiling of the refrigerant vapor that flows from the compressor is condensed and consequently flows via an expansion valve into the storage areas to be cooled will take place. The evaporator is normally installed inside a closed vessel with metal walls. 3. Condensers. The compressor lubricating oil that circulates together with the coolant has a great effect on the performance of the condenser. This oil tends to adhere to the walls of the condenser tube and forms an insulating coating that reduces heat transmission and, therefore, condenser efficiency. To prevent excessive accumulation of oil in the system, an oil trap is installed at the compressor discharge. 4. Auxiliary units. A. In the event that the expansion valve of a cold storage installation is opened too wide, expansion will take place not only in the evaporator, but also much further away, causing the refrigerating effect to be extended through the entire compressor suction line. This line would become coated with frost, reducing the performance level of the installation. Diagram of a two-piston refrigeration compressor. SMOOII tube evaporator coils. Automatic oil separator. B. The safety valve in a refrigeration installation is located in the system's high-pressure zone between the outlet of the compressor and the intake of the condenser. In those cases where there is an oil trap, the valve is located in the section of line between the oil trap and the condenser. The valve communicates at its end point with the low-pressure zone, the two zones being separated by a membrane whose function it is to interconnect the high and low pressure zones in the event of a break due to overpressure. In this manner, loss of gas in the circuit is prevented. Cutaway view of a duct. Diagram of an expansion valve. 5. Auxiliary units. A. To prevent noises and vibration in a ventilator installation, the ventilator is positioned so that a liner can be inserted between the base of the seat and its support to dampen vibrations. This liner can be made of wood, rubber or any other similar material. This cushioning is especially important in the case of ventilators that are intended to ventilate living quarters. B. Although the ideal ventilation for a purifying chamber is the type consisting of mixed ventilation with forced intake and exhaust, usually, for reasons of simplicity and economy, only an extractor is installed, thereby eliminating the mixing of air and fuel vapors from the fuel and oil in the purifiers, which is very dangerous.
Diagram of an expansion valve. B. IV other equipment. The section covers a group of non-electrical items of ship equipment and machinery not discussed earlier and which, in general, are installed both on steam-driven and diesel engine-driven ships. In particular, this section covers the following equipment with its components, circuits and elements. Air compressors, pressurized vessels, levels, viscometer, exchangers, fresh water generators, septic tanks. The operating basis for each of these items of equipment is similar for both diesel engine and steam-propelled ships, some of them differing only as to the source of energy used and the capacity of the engine, according to the type of propulsion system of the ship and the importance of the effect of each item on the rest of the installation. The air compressors used on board ship are of the reciprocating type and their function is to furnish the necessary air for starting, in the case of the diesel ships, and to start auxiliary engines and to supply air to the pneumatic control and automation system for both diesel and steam-propelled ships. Operation is identical in both cases, and the only differences are the value of the pressure obtained and the volume of air produced, which are lower in the second case than in the first case. The working principle is the same as for any other reciprocating machine, so that it is not necessary to repeat those aspects common to the various types. Diagram of a compressor. On all ships there are a great many circuits that include vessels that work under pressure, either for air or for some other fluid. All of these consist of hermetically sealed metal containers tested at a pressure greater than necessary, with an intake and outlet for the fluid to be stored and a safety valve to prevent any danger of explosion of the tank. On ships, there is a great variety of systems of measurement of the level of liquids in the tanks and in the reservoirs of the machines, the most common being the gauge glass level indicator, extensively used for tanks and boilers. Electric and electromagnetic level indicators, used in boilers and bilge sumps. Rod-type level indicators which, because of the lack of precision, are used as indicators in certain engine crankcase and small unpressurized tanks, proportioners, ECT. Finally, direct probe level indicators, consisting of a graduated rod or strip introduced into the tanks by the crew member. The viscometer is the instrument used on ships for automatic checking of the viscosity of the fuel used in the boiler and engines. Correct functioning of the viscometer is essential to getting good combustion, because nowadays, due to the poor quality of marine fuels, strict control of their heating level before use is necessary. Diagram of viscometer installation. The viscometer system, as indicated in the figure, is made of various elements which, together, automatically supply the viscosity preset for the fuel involved. The exchanger or components responsible for absorbing heat from or giving heat to a fluid, fresh water, oil, fuel, etc., through a cooling or heating system. They normally consist of a pressurized metal structure through which a liquid flows, this structure through which another liquid flows in the opposite direction. Its actual operation is totally automatic, because the temperature levels that engines require nowadays have to be as precise as possible and without any sudden fluctuations. Because of greater autonomy of ships and the need for the water used on the ships to be as pure as possible, the use of distilled water generators, both for steam and for diesel installation, has become more widespread. On steamships, the equipment is larger in volume because it has to produce the water for the boilers, since steam is used in the boilers as the source of energy. On diesel ships, it is smaller in volume. The energy source is the hot water coming from engine cooling. To eliminate the human organic residues that a ship generates in the least contaminating and bacteriologically purest manner possible, ships are equipped with a septic tank installation consisting of various elements which, by a simple treatment process, convert solid of semi-solid organic materials into bacteriologically pure water which is then dumped into the sea without any danger of contaminations. Following are some points of information and practical cases involving the above-cited equipment of greatest application on board a ship. Diagram of a heat exchanger. (1) Air compressors. A. Double-acting and high-pressure air compressors are equipped with pistons of different diameters, with the low-pressure piston being the larger of the two. B. To regulate the compressed air supplied by the compressors, the intake air volume of flow is adjusted and, to that end, compressors are equipped with a flap valve in the intake manifold. Compressor production is therefore regulated by operating this valve. C. In an air compressor, oil from the lubrication of the moving parts that mixes with the air is eliminated by means of bleeders that are installed on each stage of the compressors and in the air pressure tank. 2. Pressurized vessels, pressure tank. A. Periodic bleeding of all pressurized air containers and vessels is necessary in order to remove any water resulting from moisture in the air that condenses when it is cooler and is deposited at the bottom of these vessels. This will substantially reduce the moisture which, as has been indicated, could cause subsequent problems in the systems using pressurized air. 3. Levels. A. Many ship tanks are equipped with two systems for level checking. One using a glass instrument, another involving a direct probe. To determine the exact quantity contained in these tanks, the direct probe is used, since the value obtained by this probe can be corrected through the probe tables depending on the condition of the ship, listing, trim, while the glass level can only be indicative, since in this case, there usually are no correction tables. Measurement of level during ship movements. 4. Viscometer. A. The viscometer has to be installed past the fuel heater so that the fuel reaches it at actual viscosity, thereby allowing the correct signal to be sent to the heat, allowing the correct signal to the heat steam valve. 5. Heat exchangers. A. An exchanger is a component capable of contributing heat or removing it from a fluid circulating inside it. Therefore both heater and coolers have to be considered as exchangers. B. In an exchanger, either the cooled or the cooling aspect can be automatically regulated. For instance, in a heater, it is the steam that is regulated, while in an oil cooler, it is the passage of oil through the cooler or the volume of flow of the cooling water that is regulated. 6. Distilled water generator. A. The most significant indication that a water generator is dirty is a substantial decrease in its performance, since the salts contained in the seawater tend to adhere to the pipes, acting as heat insulation and decreasing the production of distilled water. B. In the event the salinity indicator of the distilled water generator indicates a salinity level in the water produced in excess of 50 parts per million, pages p. m., the drain valve to the bilges must be opened immediately in order not to contaminate the distilled water storage tank. 7. Septic tanks. A. When it is necessary to inspect the pump or when sailing in the open sea, the septic tank can be emptied directly by gravity, without any need to use the pumps. B. The septic tank is discharged over the side through a check valve, also called a bad weather valve. The purpose of this valve is to prevent water from entering the discharge manifold during bad weather or through sudden movements of the ship. 8. Strainer. A. When a filter in the fuel circuit is dirty, it impedes the proper flow of the fluid, which causes back pressure in the circuit itself, increasing the pump's discharge pressure. B. One type of filter used in the air intake of auxiliary engines is the filter with oil bath and spongy substance. In this filter, the filter elements are both the oil and the spongy substance, because as the air brushes the surface of the oil, it deposits in the oil part of the particles that it contains. In addition to the above, it should be pointed out that the air entrains oil, making the spongy material much more efficient so that, in this way, the filtering is more complete. B. V. Fuels and oils. The continuing drop in the quality of the fuels supplied means that attention is being paid increasingly to this situation both on steam-driven and on diesel ships. Nevertheless, the problem is more important on diesel ships because alongside the above-cited problem, there is the trend towards the use of the increasingly heavier fuels, with boiler fuels being used in the big slow engines. Oil, in addition to its lubricant mission, is, with all of the above, taking on the additional function of counteracting the pernicious effects of bad fuels through the use of the additives which are ever more and more frequently. The enormous amount of damage caused by this situation, along with ignorance of the fuel process, has led shipowners to become aware and ever more concerned about this problem. For these reasons, this topic deals with the receiving, storage, treatment and utilization both of fuels and of lubricating oils and hydraulic machinery. Following are some points of information and practical cases that will be useful on board ship. 1. Characteristics and effects of fuels. A. The attached tables indicate the most common characteristics of fuels depending on the main areas of supply. B. A high sulfur content in the fuel can cause great wear and abrasion in the liners and piston rings in the engines, and reduce the life of the exhaust valves, if not checked by sufficient and appropriate cylinder lubrication. This is due to the fact that, on the one hand, solid and highly abrasive particles are involved and, on the other, that it produces corrosive acids during combustion. 2. Receiving and storage. A. Gas oil and diesel oil are of low viscosity, which permits them to be pumped even at low temperatures. Therefore, it is not necessary to keep them stored with heating. B. The same of fuel turned over by the supplier to the ship's chief engineer must remain in his custody until the fuel starts to be used and it is certain that it presents no problem, and is of good enough quality to be burned in the engine. If, on the contrary, this fuel is of poor quality, and causes problems in the installation, the sample should be sent for analysis and a formal claim filed. 3. Purification of fuels. A. When residual fuels are used in an engine, preheating in the sedimentation tanks and daily service tanks is not sufficient for the proper functioning of the purifier, because of the high viscosity of these fuels. Therefore, 1 or 2 heaters are installed between the tank and the purifier to bring the fuel up to the conditions required by the manufacturer. B. A centrifuge can be used as a purifier or clarifier by changing the discs of its bowl. As purifier, it separates solids. 4. Preparation and handling of fuels. A. The sedimentation tank receives the fuel from the storage tanks where, after settling, a daily purging is effectuated for partial elimination of solids in water. Therefore, these are vertical tanks with a small base, located in high spots to permit draining, and they must be cleaned frequently. Diagram of fuels treatment on motor ships. B. When an engine that usually burns residual fuel works on distilled fuel must be done with great care to prevent any seizing in the fuel pumps and injectors. The residual fuel must be heated slowly until it reaches a temperature somewhat below its flash point. Once this temperature is reached, fuel is made in, starting with the temperature reached as above, the temperature of the fuel and the engine speed. 5. Properties of oils and types of lubrication. A. In a lubricating oil, a high viscosity index, VI, means that the lubricant retains its viscosity and other properties over a wide temperature range. For example, a VI of 350 in a hydraulic lubricant refers to the property of the oil to perform almost the same at -50 centigrade and at ambient temperature. The attached figure indicates, for guidance purposes, the value ranges within which the viscosity index normally fluctuates. 6. Analysis and treatment of oil. A. A high index of pentane insoluble in an oil analysis indicates that there is a substantial proportion of solid particles in the system. These can be caused by combustion residues, engine erosion, the breaking down of the lubricant itself. B. The basic functioning of the centrifuges for the treatment of fuels and lubricating oils is the same. Normally, in marine installations, the difference is in their capacity, the fuel centrifuges having a higher volume of flow than those designed to process lubricants, because the volume to be treated is larger in the former than in the latter. C. One very simple way of determining the presence of water in the oil consists in slowly heating a drop of lubricant. Aluminum foil is a good support for the drop, because it permits heating without getting burned itself. If the oil contains water, when a certain temperature is reached, a small crack is heard. This simple method is known as the crackle method or crackle test. 7. Additives and fuel-oil ratio. A. The tendency at the prevent time is for engines to burn residual fuels with a high sulfur content, which produces in the combustion chamber high residues of corrosive acid materials which, in turn, can cause great wear in liners and piston. This effect is reduced to a great extent by using a cylinder lubricant with a high reserve alkalinity, TBN, which neutralizes acid materials. Modern cylinder oils have a TBN of approximately 75. B. Trunk engines are exposed to oxidation of the casing, caused by the scavenging air, and to contamination from combustion chamber residues. Therefore, the properties of the lubricant used in these engines must include high oxidation stability and a high solid dispersion capacity. In addition, deposits of dirt are produced in the casing, which has to be cleaned by the lubricant. The latter must, therefore, have a high detergent capacity. 8. Hydraulic oils. A. The hydraulic oil both of the servo motor and of other equipment deteriorates over time, so that it is not considered advisable to use it for more than 1 year without checking its properties by sending a sample for analysis. These oil breakdowns are due chiefly of moisture. B. Viscosity is the most important property of a hydraulic oil, because it is directly related to the efficiency of the system. As a consequence, a high viscosity with variations in temperature. This property is truly essentially on ships that sail in weather areas. 9. Other lubricants. A. Keeping moisture out of a cooling oil is important to prevent corrosion, the breakdown of the cooling fluid, and the formation of ice in the system. Therefore, great care must be taken in storing these oils in dry places in enclosed containers. B. Transformer oil must have a high insulating capacity against the passage of electricity and is manufactured especially for use in such equipment. Of these oils, the best grades are the antioxidant transformer oils, which withstand temperatures higher than normal and have a long service life without breaking down. Thank you so much.